Welcome to our webinar today, 7 Common Questions about a Cloud Management Platform. And thanks for taking the time to spend an hour with us and learn a little bit more about cloud management platforms and what you can expect from them. We're going to be hearing today from Mitch Gerdish, who's a cloud solutions engineer at RightScale, so an expert on the cloud as well as cloud management. So he'll be able to answer some questions, talk about some of the common questions that people have, and also provide us as we go along with an in-depth demo. A couple of logistics items before we get started. We will be taking questions at the end of the webinar, so please feel free to put those into the questions panel of GoToWebinar, and we'll get to as many of those as we can. If we don't get your question answered, we'll follow up with you afterwards and make sure that you do get an answer to that question. We will also be providing an email or sending an email with a link to both the slides and the recording of the webinar. That should come out within 24 hours after the webinar is over. So that will enable you to review the slides or share the recording or slides with somebody else within your organization. So the questions that we're going to be talking about today, we're going to weave throughout the presentation today, but we'll try to highlight these as we go through. So first is really the problem of managing multiple clouds, and can a cloud management platform be used to manage multiple clouds? Do you have to change what you're already doing in the cloud? A lot of people we talk to are already running applications in the cloud. They may have different business units running in different clouds. In order to use a cloud management platform such as RightScale, do you need to start all over? Do you need to redeploy things? Does it only work for Greenfield, or how do you take on those existing applications? Often a CMP might be championed by one or the other of the ops or IT organization, or possibly the dev organization. But really, if you've got both people involved in the delivery of software and the use of infrastructure, how does it serve the needs of both? What about continuous delivery? If you're doing continuous integration and continuous delivery, or moving along the path towards doing that, how does a CMP fit in, especially in conjunction with tools you might be using like Jenkins or other types of continuous integration tools? You might ask, hey, I've got my native cloud provider tools, so maybe I'm using AWS and Azure, or maybe I'm using VMware and Google, or OpenStack and something else. Is there a reason I shouldn't just use those consoles that come with each of those tools? Docker is a hot topic now, so what's going to happen as people are starting to adopt Docker? Is that going to just solve all my problems? How does a cloud management platform fit in conjunction with this? And then you also may have some questions about optimization or costs. So obviously there are costs associated with both public clouds and private clouds. Is there a way I can leverage a CMP to help me optimize those costs or reduce those costs? So those are some of the topics that we're going to be covering today as we go through. So before we dive into the content, we're going to do a couple quick polls just to get a sense of you, the audience, and you can get a sense of each other. So let's go ahead and ask our first polling question, which is really, how many public and private clouds do you currently use? So this would include public clouds like AWS, Azure, Google, SoftLayer. It would include private clouds, whether that be like OpenStack or CloudStack, or maybe you have a hosted private cloud. Maybe you're using your VMware environment as a cloud, so that would count too if you're using it in that way. Some people have developed bare metal clouds where they're using bare metal in sort of a cloud-like fashion. So if you could specify how many total across all of those you're using, none, 1, 2, 3, or 4 or more. And we'll give you a couple more seconds to answer that. And then we'll go ahead and share the results. And we can see that the biggest number here is 2, so about a third of you are using 2. We've got another 40% of you that are using more than 2, 11% at 1, and 20% none, or 19% none, although that's probably none yet, I suspect, for those of you on this call. All right, let's do a second polling question. And the second polling question is whether you use a cloud management platform today. So you can answer yes, no, but you're planning to, no, or you're not sure. So select the one that's relevant to you. And then we can go ahead, give you a couple seconds, and share the results. So about a quarter of you have or are using a cloud management platform. About a third of you, a little more, planning to, third not, and 8% not sure. So kind of a even distribution between those three groups. All right, one final polling question. And the final polling question is about what problems would you like to solve with a CMP, whether you're using it today or maybe thinking about using it, or maybe you haven't thought about using it. So here's a few items, and you can click more than one of these. So would you want to get visibility and governance across multiple clouds? Would you want to provide a self-service portal for, say, your developers or other cloud users that would allow them to deploy standardized stacks or applications into different clouds? So that'd be multi-cloud self-service. Would you want to really have an operational view across multiple clouds so you can see what applications are running, but also monitor them, get alerts on them, maybe do patching and updates, other types of operational activities? Would you want to do cost management? So look at the costs on different clouds, maybe forecast costs, maybe optimize costs, maybe compare costs between clouds? Or would you also want to automate infrastructure for a continuous integration, continuous delivery, or DevOps process? All right, so let's go ahead and share the results with everybody. So looks like the top thing is really visibility and governance. Everybody wants to see what's going on and know what's running in which clouds, and put probably some access controls and governance controls on that. Second is cost management. So this is something we see commonly as well. It's like, okay, I'm starting to use the cloud more. The costs are starting to go higher. Maybe I need some help to keep those under control or reduce those. Self-service is also common, and then operations. And then the last one is automating for DevOps and CI/CD. Okay, great. So with that, we'll finish up that poll. And let's go ahead and move on and jump into some of the content. So just as a comparison, RightScale does a State of the Cloud report every year. And the one that we did at the beginning of 2016 found these results, where we asked people what clouds they were using and then looked at how many each company or person was using. And what we're finding is that on average, companies are using 1.5 public clouds and 1.7 private clouds that they're already running applications in today. So that's an average of 3. And experimenting with about an additional 3 clouds as well. So meaning maybe they're running in AWS and looking at Azure, or running in Azure and Google and looking at AWS, whatever that combination might be. So really the world today is definitely a multi-cloud world. And what happens as you start to use more than one cloud, and you can have issues certainly even with one cloud, and there's reasons to use a CMP associated with that. But as companies start to combine public and private, or their vSphere and public clouds, or multiple public clouds, the problem sort of expands and explodes from there. And the reason is that each cloud is going to be a bit different. And so it's going to have a different console, it's going to have different features, it's going to have different ways to use it and capabilities. And so it really creates a model whereby your developers or your ops teams are having to become experts across many different clouds. And that can be a bit daunting as the cloud use continues to grow. So really what RightScale does as a cloud management platform is enable you to really manage that from a single console or a single pane of glass. And in our case, we call ours a universal cloud management platform because we support, of course, public clouds, private clouds, but also virtual servers, so your vSphere environments or other virtualized environments, and bare metal servers, so we added support for that last year. So if you're treating bare metal servers as a cloud or want to treat it as a cloud and use it, you can bring that into the fold as well. And RightScale does this with a SaaS-based platform. So it in itself is a SaaS platform that you can simply log in, set up an account, and begin using. So that makes it super easy to connect to all of your various clouds that you have in place. And within the RightScale platform, there's a variety of different type of capabilities that are really targeted to different audiences that are using cloud. So for example, the self-service module is designed for consumers in your organization of cloud services. So that could be your development teams, that could be maybe people in your training group or your demo groups, or people that need to consume cloud services or deploy applications that are going to run into the cloud. The cloud management module is really your operations team. That's their home base. So this is where they get visibility and governance over everything you're doing in the cloud. They can set up monitoring, alerting, management, do updates. So it's that single pane of glass, ensuring that you can meet all of your SLAs. And then cloud analytics is really designed for the people that are going to care about cost and usage. So that can include tech people, but also finance and business, who are going to be looking at what's been used and how much that's costing. And really underpinning all of this is a layer of governance that goes across the entire platform that helps you control who does what, when, and where. And so that's really the big picture. So one of the questions that we had actually even prior to starting is whether this is for companies that are developing their own SaaS software or whether it's companies that are doing something internally. So really customers of RightScale span the whole spectrum. So some of them are software companies that are delivering their own software often as a SaaS solution, but a large number of our customers are traditional enterprises. They could be in financial services or in healthcare or in media and entertainment or in retail or in a whole variety of different industries. And what they're really trying to do is manage applications that either are deployed in the cloud or virtualized environments or are going to be, and they're trying to do that to really help increase agility in their own internal organization. So either of those are really reasonable use cases. The other thing that I want to talk about is this problem that often comes up is what I'll call least common denominator. So as you're trying to talk to multiple clouds, the question becomes, if you're using a single console for that, how do we do that in a way that enables me to still use the special features in a particular cloud that are constantly changing and constantly getting added to? And so that's an important thing for a cloud management platform that RightScale has solved in a particular way, which is first, obviously, all the basic features that are going to be in pretty much any cloud, compute, storage, network, database, those are going to have built-in integration. They're going to be ready out of the box for you to start using them and managing them through the RightScale CMP. But we know that there's constantly new features coming out or things that you want to use that might be outside of that. And some of those could be things from the cloud providers. So, every time you go to an AWS conference, they'll announce like 10 new services. Azure's been adding a bunch of stuff to their platform. Google's also coming after it. There might also be third-party services that you're using. So you might have a DNS service, for example. You may have your own internal web services that you need to leverage for some of your application. And so we have a concept called a cloud service plugin. This is a framework that enables you to plug in and talk to any of those particular environments that you need to talk to orchestrate that and to manage that. And those plugins could be created by RightScale. So we can provide plugins, part of our out-of-the-box or also customer service engagements. You can create your own plugins. So this is something that's possible for you to do. Or if you have a service provider, a third party, they can create plugins for you as well. So it enables you to ensure that this can expand over time and you can use it to manage anything that you might want to. So with that, I'm going to turn things over to Mitch, and he's going to dive in, give you a demo, and along the way talk about some of these 7 common problems.
Okie dokie. Once I get my screen over here.
Let me give you access here. Just one second, Mitch. So we're going to change control here. So just give us one moment to make that change.
There we go. So what I'm going to be doing is walking you through the platform, those 3 modules that Kim mentioned. There's self-service, cloud management, cloud analytics. But I'm going to be taking you through the platform in the context of the adoption levels. There's basically a day 1 adoption level where you get your account and you register some cloud environments, maybe a VMware environment, and what can you do on that day one? Then when you go, then the next stage or the next level of adoption is to start enabling those VMs, those instances with our agent, and what that brings along with it. And then the third level of adoption is generally where you start leveraging the automation capabilities that RightScale can offer you. So day one, what happens? Well, what happens is you're going to get an account. You'll have an enterprise, what we call an enterprise account, and underneath that you'll have one or more what we call child accounts. This is basically where you connect your various cloud environments, your various VMware environments. This is also where you can manage your users and what permissions they have across those different accounts. For this demo, I will be using this one account here called RS Demo Hybrid Cloud, but just understand that this enterprise actually has several accounts under it and several user permissions across those different accounts. So we have various accounts, various child accounts. We'll be using the one that I mentioned, and then just to kind of give you an idea of how you can manage users' access across those accounts. You can see, for example, Aaron here has limited access to a couple of accounts and no access to others, whereas Adam has lots of access to some accounts and none to others, for example. So you get your accounts. Then the next step is to register cloud environments with it. And so in this example, in this account, we have Amazon, right? We have all the various several Amazon regions, several Azure regions, Google, some OpenStack environments, and even VMware. And just a note on VMware, we have essentially a native integration with VMware in the form of what we call our RightScale Cloud Appliance for VMware. It's basically just a VM that you would run in your vCenter environment, and it acts as a liaison between vCenter on the back end and RightScale, the RightScale platform on the front end, essentially presenting that vCenter environment just like any other cloud. And you can see those sort of common cloud constructs that get presented here. Images being, VMware templates, but a construct such as instance types, which is definitely a very cloud-oriented construct. And the other thing to note is for those private environments, you are able to set pricing for the different CPU RAM combinations, or if we're talking OpenStack, the different flavors. For the public environments, that's all automatically consumed and processed by our cloud analytics, and we'll see more of that when we get over there. So you have accounts, you've attached some cloud environments, and what happens is the RightScale will start, your account will start discovering what's in those underlying cloud environments. And what will happen is any instances that are already running there will be discovered. And so I have a set here at the top here, these pink ones here. These are what I like to refer to as raw instances. They are not managed by RightScale. They were there in the environment beforehand, and when the clouds were attached, they were discovered. And what you should know, a couple takeaways from here is this idea that I've discovered, these instances have been automatically discovered. They are across multiple environments. In this case, we have one in Amazon, Google, Azure, VMware. And my abilities with these instances will be very much akin to what I can do in the native cloud console. But the nice thing is I'm not switching between different cloud consoles. And even within those, like Amazon console, I'm not switching between regions. I can see it all in one place, manage it all in one place. And some of that management, besides just the basics that you'd kind of expect to see, is that you can actually at this point start applying tags. Now, if there were tags already on those instances, like in Amazon or Google, those would be discovered and presented here. But I could also add additional tags that get pushed down to the underlying cloud. But even more interesting is I can start creating tags and applying tags that are at the RightScale level. I have a tag that I'll call project, a namespace called project, and the ID is a key, and the value 1234, for example. So maybe I have a bunch of instances across multiple environments, multiple regions, perhaps even at that level. And now, but they're all related somehow. They're all related, say, to this given project. I can apply that project ID to those different instances day one. And now, when we get over to Cloud Analytics, you'll see how I can use that to actually do some cost analysis day one. I haven't done anything but connect my clouds. and add some tags as I wish. The other thing that you can do is actually start grouping instances in a construct, a RightScale construct that we call a deployment. It's just a way of grouping servers. It's a way of grouping instances so that you can manage things a bit more concisely. It's not just this big flat list of instances, but you can actually start pushing them into individual deployments and now have a place where you can say, okay, this application is, all the instances of this application are in this one deployment, and I can start managing at that level. So day one, you can start tagging both at the down all the way. You can continue pushing tags all the way down to the underlying cloud, or you can start tagging at the RightScale level and get a cross-cloud, cross-region, cross-environment tagging infrastructure in place. You can start grouping them into deployments and start managing at that level. The other thing that happens day one is the networking is discovered. And so, for example, if I just drill into my Amazon environment, that day one connection, again, all you did was connect your cloud credentials, will discover, the VPCs, the subnets, the security groups. At this point, you can actually start to add, continue to manage those existing VPCs, security group subnets. You can add new ones, again, all through this one console. One thing I should have mentioned at the beginning, actually, is that everything I'm showing you through the UI today is also accessible through API. So we're an API-first product. Everything I'm showing you and will be doing, you can also do through API. Now, one of the other things that happens on that day one discovery and ongoing is that this network map is created, the security group map is created. So here I can look at what's open to different security groups or different CIDRs. So in this case, I can see everything that's open to the internet. I can drill further in, and I notice that I have, for example, 3306 open to the internet, which is usually not a good idea. So I can figure out, okay, which one of these security groups has that open to the internet? It looks like these are the ones, and I should probably go in and fix that. So, very handy monitoring tools, auditing tools, I should say, to start getting a handle on what's going on across your different environments. So, day one, you can start doing some operations management, and you can start doing some financial analysis. You can start doing some cost analysis. You can start creating reports and alerts that I'll show you. So again, what's happening is at this point, the system is discovering what's running out there. It'll just start consuming and looking at comparing that to the pricing that it knows about. And that pricing, again, for public clouds, we're gathering that on your behalf across all the different clouds. Even within Amazon, across, if you start thinking about the different prices across the different regions, the different instance types, it's tens of thousands of data points that are collected on your behalf. Now, analytics really starts to show its power when we start looking at the analyze view. So, for example, I can start setting up sets of filters to essentially create a projection through data, through all that cost data for a given use case. And as you can see, these are all the different things I can filter on. I mentioned tags. So again, day one, I haven't done anything but connect some clouds and maybe start to apply some RightScale level tags, cross-cloud tags. I can use those tags to say, show me everything that's all the costs associated with that project ID 1234, for example. Similarly, I could, those deployment constructs I was mentioning, that you can start grouping things under deployments, you can just say, okay, show me all the costs for that one deployment or this set of deployments. I can look across multiple RightScale accounts as well as multiple cloud environments and data centers and regions. Basically, everything you see here, you get day one. Some of the constructs don't apply day one because this has to do with the automation like server templates and cloud apps, but we'll talk more about that when we start talking about the subsequent levels of adoption. Once I've picked a set of filters, I can use those to create reports. So here I have a couple examples of some reports. So for example, here I'm looking at one of my RightScale accounts. In fact, it's the account we're generally using for the demo. And I have I'm looking at a specific tag, in this case, a cost center tag. So basically every week I get a report that shows me the costs associated with this account, with this tag in this account. Basically any server, any instance that has that tag in that account will be represented in this report. It'll show me my spend over that previous week. It'll also compare that to the week before that. There's a CSV in this case attached, so I can look at the details. I can see everything that came and went over that week, and any, some of the attributes. In this case, I'll also see tags associated with those entities. As you can see, it could be a daily, weekly, or monthly report, and voila, I get again, however you want to look at your costs. I can have this sent to anyone, any number of people, whether it's myself as well as, maybe my manager, maybe who's ever in charge of the finances. Other examples, this one is just, again, same idea, but now I'm just looking at one user's, in this case, my spend in that account. It should be noted and, reiterated that this set of filters is completely customizable in terms of what you want to filter on and how many things you want to filter on. There's no hierarchy here. That can be, across multiple accounts, across multiple clouds, across multiple users. You can also set alerts, and alerts are what they sound like. So whereas reports are just pretty much telling me what I spent in that last period, alerts are to look for overspend, right? So in this case, I have an alert that's defined. It's looking at the costs for this one RightScale account. There's a monthly budget for that account of $1,000. And basically what will happen is when someone who has access to that account launches something, or essentially causes that $1,001st to be spent, since this is an actual spend alert, the alert will go out at that point. It'll go out to me, it'll go out to anyone else I have it going out to, and in this case also have a CSV attached. So at this point, and that's a sort of a reactive scenario, right? So I've already gone over budget. Now I'm going to react to that. But nonetheless, you can start to react to it. You are notified of it when it happens. Another example is a forecast spend alert. So here, I am looking at one individual's use in one account. So again, my use in that one account. I have a $400 a month budget, let's say. And in this case, when it looks like I'm going to go over $400, then the alert goes out. So maybe I've only spent $100, but based on my current trends and usage, the system predicts that I'm going to go over, that this set of filters will go over $400 by the end of the month. The alert goes out then. So now it can be more proactive. You can figure out, okay, well, I expect that the early part of the month I'm actually doing a lot of work, but the later part of the month I won't, so I should be okay in the long run. Or maybe I need to use some of the scheduling capabilities that I'll demonstrate in a little bit to make sure I'm only running these servers when I really need them. There's also a scenario builder tool which lets you do planning, cost planning, looking at different environments, different clouds. And so, for example, I'll just do a quick blank one here. I'll just go in here and add some instances to my scenario. So let's say we're working on a new application, a new multi-tier application. We're not sure exactly where we want to launch it, but we have access to Amazon, Google, Azure, and even some private environments, let's say. And this tier, I don't know, needs 8 CPUs, I don't know, 16 gig of RAM or something. And what I can see here is my options, basically the instances that meet those requirements and the costs. Here I'm looking at some Google options. Here's some private environments. Again, because I've set pricing for my private environments, that'll show up here. Here's some Amazon choices. Here's some Azure choices, etc. So let's say I just picked this guy, and I expect I'm going to be running it in US East, and we'll just kind of keep this quick and dirty here. I expect to only run it a couple, half a day, so I'll have scheduling set up to shut it down half the time. And I can add this to my scenario. So now I have this basic one tier showing me what it'll cost to run that across 3 years. But maybe I want to start adding a bit more. Again, I can go through that same sort of process, pick a few things here. I'll just pick something, again, somewhat randomly. This one I'll have run 24/7. I'll let it be an AP Northeast, whatever. And so now I'm building up, this profile, this picture of what it'll cost to run this application. However, I can do a few other things. Maybe I expect this tier to grow by, I don't know, 10% a month. So now I can see how that'll affect the price. Maybe this other tier will have some seasonal bump up. Maybe it's related to processing beginning of the year taxes or something like that. I can also apply, in this case, since we're using Amazon, I have the option here of looking at what does it look like if I apply different types of reserved instances. So let's go with a 3-year partial up front, get that out of the picture, and see what that looks like. As you can see, it drops down a little bit. I get some cost savings. And I can do this all day long, right? I can create these various scenarios, look at the various options across different environments, different clouds, and make intelligent decisions about how best to where best to launch. There are other tools here. There's a utilization report. I'll leave without saving. That is in beta, but again, the idea is our goal is to get the sort of analytics to action connection, right? So we're collecting this data. We know what's going on in terms of cost. How can we use some of this information to make intelligent decisions about placement, about instance sizing? And I will use this opportunity to reiterate, this is all day one stuff, right? Up till now, I haven't needed to do anything but connect my clouds. Now the analyze, the utilization report is starting to leverage some of our monitoring because in this case, I'm able to look at, in this case, memory utilization and CPU utilization. And here I have a few different instances. The size of the bubble is the size of the instance. And I can look and say, the system will say, okay, it looks like you have some wasted cost here. I mean, it's not a lot. This example is not, the most egregious example. But basically, it's indicating that I have some instances that are underutilized. And I just have to make the decision, well, maybe I want them underutilized because it's a standby server, it's a backup, or I can now make intelligent decisions about sizing. I can use a smaller size, again, making analytics to action type of decisions. All right, so now day one, I've got all this data, I'm generating reports, excellent. But now I really want to get into, start leveraging some of the next layer of capabilities within RightScale, which has to do with automation, applying our agent, monitoring. And that comes in the form of basically what we call a server template and our right-link agent. So if I go look at a deployment here, the first thing you should realize is I can take those raw instances I was showing earlier, those unmanaged instances, and I can perform an operation that we call right-link enabling them, essentially applying our right-link agent, wrapping it in what we call, in a construct that we call a server template, and then getting all the power, all the manageability that comes with that. So if we look at a running instance, so that what I'm looking at here now is I'm going to click in and we're going to look at a running server. This is an instantiation, not just an instance, but an instance with our agent and wrapped with a server template, which I'll talk a bit more about in a minute here, and what it provides you. So if you remember when I looked at those unmanaged instances, I just had a couple options like terminate and reboot. Now I have various other options that are enabled by enabling it with the right-link agent. One of those aspects is that I get monitoring. So we use a collectd agent as sort of the monitoring infrastructure. This, you can basically write your own collectd monitors. You can go to the collectd community. We have various packages of monitors that you can install. Our right-link agent, our right-link 10 agent also even has a native monitoring capability in case you don't want to use collectd. But nonetheless, with collectd you get all the flexibility and all the options you can imagine in the world. So here we see some standard server level monitors, disk, interface, memory. But in this case, we're looking at a MySQL master. So in this case, there's actually a MySQL related set of monitors. So I can see, what's going on in terms of my MySQL performance. And these monitors are great, right? I mean, they're great in the sense that you can get a glance at what's going on. You can see what's happening at the different layers, the different aspects of your server, of your VMs, instances, whatever you want to call them. But these monitors can also be used to automate action, recovery action. And that comes in the form of our alerting infrastructure. So basically what you're able to do is define alerts, conditions, if you will, related to those monitors that you have installed. And based on those conditions, take action. So in this case, in fact, we have this one set up to actually be alerting. What it's looking at is the database backup age. So essentially it's alerting because the MySQL database has not been backed up in a long time. And so it's alerting. It's an active alert. It's firing. And the alert action is represented by these escalations. These are just some of the default ones, but you can define any set of actions you would want. In this case, it's just sending out emails. But you can have it do anything from sending out emails. You could have it run a script, so you could automate recovery. So in this case, what I would probably do is I'd have an escalation that the first order of business is, well, let's run a script to force the backup. If the alert keeps firing for say 5 or 10 more minutes after that script has been run, now I'll start maybe sending out emails to maybe the person who's in charge of this server. If it's still happening, say, an hour later, now I'll start sending out emails to a team, right, a team alias. If it's still a problem, I can actually escalate if I want to the point of rebooting the server or even relaunching the server, where I'm essentially tearing down, destroying that server, and then building a whole new one, all through the automation that RightScale enables. So again, once you enable with the agent, you start getting monitoring, you start getting alerts, and you also get audit entries. So essentially, everything that's happening on that server can be logged in terms of, in this case, what we're seeing, all these completed email actions. That's the alert that's been firing. Also, we're seeing managed login policy. We have a managed login capability that allows you to control who can log in to a server, who can SSH into the server. In fact, there's special permissions roles that users get that indicates whether or not they can SSH into a server through the managed login capability. And in fact, I can go back to the beginning of time of this server, which extends way back into last year. And if I go back to its very beginning, I'll see the launch sequence basically coming operational. I see that some additional scripting was run to enable and set it up. I see that Bruno here actually logged into the server. Bruno actually ran a script. He's no longer on the account, but his record remains. So these audit entries are here for a very long time. The promise is 3 years. We generally keep them longer. And again, since we have API first, a lot of customers will actually offload the audit entries periodically to have their own copy. So let's talk a bit about this concept of a server template. So once I can enable a raw instance, and now getting all those features I just showed you. But now I also want to start launching new instances. I want to launch new servers. I want to build new applications. I want to build additional instantiations of existing applications. That's where that's the first tier of that is, or the first layer of that onion to do that is is in the form of this server template. And what you should realize is a server template is a definition of how to build a given type of server. It's a cloud agnostic construct. It just knows that I'm building, in this case, a MySQL 5.5 server. We'll go look at an example and see how it does that. But basically, the sort of key takeaway here is I have a MySQL 5.5 server template, Rev 39 here. It's being used for 2 different roles, master and slave, as well as 2 different environments, 2 different clouds, Amazon Oregon and Azure West Europe. So this same server template, which embodies how I like to build my database servers, is able to be reused over and over again across different environments. So let's look at a server template. We'll look at this one here, and it gives a good sense of a couple of key aspects of our server template automation. The first sort of key or first main component of a server template is what image to start with, right? I mean, when we talk about clouds or even when we're talking about the VMware environment, the idea is the RightScale will talk to that underlying environment and tell it to launch an instance or a VM based on a starting image, or in the case of VMware, a VMware template, or Amazon is going to be an AMI. Once that instance is up and running, the agent gets installed if it's not already installed, and that agent then goes off and phones home back to RightScale essentially and gets its marching orders. So in this case, we're starting with a basic Ubuntu server or a CentOS or whatever. These are all the various options. You'll see a construct here called a MultiCloud Image, which is the abstraction layer across the different clouds. So what we're looking at here is this thing called an Ubuntu MultiCloud Image, which is really a reference. It's a pointer to AMIs in Amazon, images in Google, images in Azure in this example. We don't store your images. We don't store your VMware templates. Those are always kept in your underlying cloud, in your underlying accounts. All this is giving the system a pointer to those things so that the server template knows where to start. Once that instance is up and running and the agent is phoning home, it's going to get its marching orders. In this case, we're using a couple of key ideas here for the config management. So there's a boot sequence. This boot sequence gets executed in the order shown. This boot sequence is using a built-in scripting capability that we call write scripts. Basically, it's any server native scripting. So PowerShell for Windows, Bash, Python, Perl, Ruby, whatever you have an interpreter on that server for, that you could run the script essentially at the command line is a write script. In this case, these write scripts are doing some server level configuration, server level based stuff, including the installation of the collectd and the monitoring. But then it's actually installing a Chef client and then instructing that client to reach out to a Chef server outside of, that's being maintained within RightScale if you want, or it could be hosted Chef, or even if you use Puppet, it's the same idea, right? Get the Puppet agent installed and instruct it to go reach out to a Puppet master to get its manifest. But essentially what's happening is, at this point, the config management is coming from that external Chef server. There's also going to be, generally for server templates, you'll have a set of operational scripts. And these will be scripts that are lifecycle management type scripts, things that, when I go through this boot sequence, it needs to bring up a MySQL server, but I don't necessarily want every one of these to be a master. So I'll have operational scripts to create a master, create a slave, import a database, those sorts of things. And then there'll be decommission scripts, things like removing itself from the Chef server. If this was registering with DNS, say, it would remove itself from DNS. If we're talking like a Windows server, it would, the boot sequence would have an AD join and the decommission would have an AD leave, that sort of thing. The server template, you also get to define the alerts. This one doesn't have any, but I can also define alerts in a consistent way so that every time I launch a server based on the server template, not only do I know what I'm getting, because it's all revision controlled as well, but I also know how it's being managed. So repeatable, consistent processes. And this is where CI/CD can leverage launching instances based on these server templates. Now, let's head over to self-service, where now we take another step up. So instead of building individual servers, we're going to build entire applications. And that is done through a construct that we call a cloud application template. Basically, it's an orchestration construct that is saying, okay, build me, X number of these types of servers, and it's going to leverage those server templates we just talked about, right? It's going to say, spin me up 2 database servers, spin me up a scalable tier of PHP servers, spin up an HA proxy load balancer, or you can even, the cloud application templates and self-service through our self-service plugins, the cloud service plugins that Kim mentioned earlier, can even reach out to external PaaS offerings. So maybe you want to use ELB for the load balancer. Maybe you want to use RDS for the database. The cloud application template can orchestrate the creation of all that and orchestrate the configuration of all that so that at the end of a launch sequence, I have a working application. Just to give you a sense of some of the options, and I'll do this relatively quickly given the time. This LAMP stack, for example, basically, in this case, I get to pick an environment, Amazon, Azure, Google, VMware. But you should note that there's some policy here that that I've developed, that I've put into the Cloud Application template. You should also understand that these options are completely customizable by you. You have complete control over what you're presenting, even if you are going to present a cloud option to the end user, and if you do, how you want to present those. In this case, I'm just letting the user pick different cloud vendors, and I've made the decision as the policy of the Cloud Application template is that if they pick Azure, for example, it's going to US East. If they pick Amazon, I don't know, it's going to US Oregon. Whatever the use case requires, whatever the customer requires, whatever that user base requires can be encapsulated in these Cloud Application templates. I can also drive tagging through here. If you remember, I had a report earlier that was looking at a cost center tag. So again, I'm not relying on humans to individually apply the tags. I let the Cloud Application template apply the tag in a consistent way so that it's always correct, it's always the right value. In this case, the user does get to pick a few values, but there might be other tags that I apply that are driven by the very fact that it's being launched in this account or by a given user. Another key aspect of Cloud Application templates and the launch sequence is the scheduling. I can say, does this thing run 24/7? Does it run on some sort of schedule? And these schedules, again, you have complete control over what schedules you define and which ones you make available for each cloud application. So in this case, if I pick this Monday through Friday, 8 a.m. to 10 p.m., as I called it, it's going to run till 10 p.m. tonight. It's going to shut down. It's going to start up tomorrow at 8 a.m., run till 10 p.m. Do that Monday through Friday. It won't run on the weekends. Next Monday, it'll pick up again at 8 a.m., run, and do that Monday through Friday thing forever and ever and ever until I terminate the application, or I can set an end date. So in this case, let's say I'm going to be testing for a couple weeks or something. I can set it for May 13th, say, and on May 13th, it'll completely terminate and won't even do the Monday through Friday, 8 a.m. to 10 p.m. thing anymore. Just to give you a sense of other options that are available, again, to give you a sense of make you start thinking about how you can leverage this, the Cloud Application Orchestration. In this case, the user doesn't pick a cloud. All they specify is whether or not they're using sensitive data or not. If they say yes, they are, the Cloud Application template policy is that it's going to use the VMware environment. If they say no, the policy is to go use, I think in this case, an Amazon environment, just as a way of saving the internal resources. This one, for example, is leveraging our pricing information. So in this case, the user just specifies some CPU and RAM constraints, and the Cloud Application template goes and finds the cheapest place to launch, which might be your private environment, depending on how you set up the pricing, or it might be a public environment. Whatever it finds that's connected to the account that's cheapest to meet these requirements will be used. And then finally, once it's up and running, once you've launched something, once the CAD is up and running, you have, again, complete control over what the user can do post-launch. So in this case, the user gets a link to the application. This is essentially pointing, in this case, to an 8K proxy load balancer, which is talking to an application tier, which is basically just reading a database table and reporting back, something very simple. But then, but again, whatever makes sense for the use case. And if I look at, I'll show you another example with many more options, many more outputs presented to the user. But you can also specify post-launch actions. So in this case, the user can do some manual scaling if they want. They can even update the application code. So here I can update to a different Git repo and branch. In another example, I might actually have separate fields where they specify the specific repo, the specific branch, the specific commit ID, those sorts of things. So at this point, what's happening, because I selected the blue, it's going to update this to be the blue code instead of this yellow code. Other examples here, we have a Kubernetes Stack, for example. So I know there's some questions around Docker and what have you. Well, the idea is you can use RightScale to launch that Docker infrastructure and manage it, and then layer on top of that automation to drive images and images into those Docker containers and get your microservices up and running. So in this case, I have access to the Kubernetes dashboard, but I also have the ability right from the RightScale self-service UI to install, in this demo example, a Hello app, but it could be any, again, I could present to the user any sort of options that make sense for them to be able to specify what to install on that cluster. A couple last items to note is, like I said, everything's API accessible, but if you do want to use the UI, you can skin it to your own colors and logos and present, white labeled experience to your end users. So with that, I think I will turn it back over to Kim.
Great, thanks, Mitch. So we're going to start with some questions. We have a lot that have been coming in, so let me kick it off with one for you, Mitch. Please describe the methods for authentication to the cloud management platforms.
Yeah, thank you for that. Yeah, so as so we have a local username password capability if you want to use it, but we also support single sign-on. So you can set up any SAML 2.0 IDP can be used to access the environment and handle your authentication that way. So for example, we have a couple test examples there. Go ahead.
Okay, great. Let's go on to some other questions. So, sorry here, I've just got a little technical difficulty. Just give me 1 second. What is the state of the cloud, or the state of the art of orchestration on different commercial cloud platforms such as AWS, Google, vCloud, OpenStack, etc.?
Yeah. So again, our cloud application templates, without again being time limited, these cloud application templates is a full-blown. Oh, I see. I'm sorry. I thought. There we go.
I'm giving you control back there,
yeah,
so you can
that's a good
show
idea.
stuff.
These cloud application templates, although I was just kind of pointing at squares, can have a full-blown orchestration language. If you're familiar with CloudFormation templates, they have those same sort of concepts of declarative, defining what you want to build, but more importantly, they also are able to execute what our RightScale cloud language, which is a workflow language that lets you orchestrate those servers, lets you orchestrate bringing those different servers together. Like I said earlier, when I did that launch of a LAMP stack, I didn't have to do anything to get this working LAMP stack, right? Everything I did, once I pushed that launch button, it was basically up and working. And there's our blue code, by the way. So I would say state-of-the-art orchestration comes in the form of our cloud application templates and those cloud application templates' ability to not only orchestrate those individual servers, but also to reach out to other services if you want as well.
So we've had a couple questions related to some of the native tools. So for example, if somebody has a CloudFormation template, which is an AWS construct, or an Azure ARM template, how can you incorporate those into what you're doing here?
Yeah, so one end of the spectrum is you can let these cloud application templates actually reach out to, say, the Azure API or the Amazon API to run your CFT or your ARM template for you. Quite honestly, my feeling, my stance is, generally speaking, it's you can easily translate those CFTs or templates into a cloud application template, and then from there add all that capability around the workflow language. We actually do have some tooling that'll take CloudFormation templates and create a cloud application template, one of these things that we use, and then you can use that as your starting point.
So essentially you could continue to use sort of the proprietary template, in which case you're going to have different templates on each cloud, or you could really turn it into a cloud application template, which is going to give you that sort of multi-cloud capability.
Exactly.
So we had a question about images, about the fact that, for example, AWS updates their images monthly. How does that work within RightScale? Maybe talk a little bit about how you use images within RightScale.
Yeah, quite honestly, most of our customers manage their own images anyway, in the sense that they're going to have specific requirements. They're building their images, and again, through our API, what you can do is essentially when that new image is known or discovered or created, again, which is generally the use case that we see where our customers are managing images, that same automation that created that image or discovered that new image can then drive an update to the multi-cloud image, which again is that construct that the server template references. So the server template doesn't really care. It's going to work the same, no matter what. But you can then, like I said, use the API to keep your multi-cloud images up to date, drive those up into the server template, and then let basically everything else flows the same as before. It's really nothing more, nothing less than that.
All right, so a question about hybrid cloud. So how does RightScale work in a hybrid cloud environment? How easy is it to integrate RightScale with an in-house private cloud?
Yeah, so again, in-house private clouds like OpenStack, CloudStack, and even non-clouds like VMware, vCenter, are natively supported, right? OpenStack, CloudStack, and then VMware through our RCAV, all natively supported. Now, if you start talking about some other virtualization technology, which aren't clouds, right, but virtualization technology, like say Zen Server or something, you have a couple options. One option is to wrap it into something like OpenStack, in which case at that point then you just connect it up just like any other cloud. The other option is you can leverage our Universal Cloud Appliance as well as those cloud service plugins to essentially interact with that virtualization API to launch things, and then this other thing, our Universal Cloud Appliance, which I really didn't talk about too much, allows you to then drive those servers up through into the RightScale dashboard for visibility and management.
So we have a question about scaling, and does RightScale have the ability to scale up, and I assume that it could also be scaled down, and asking about whether that's CPU, memory, instance size, and I thought maybe covering both sort of the horizontal scaling but also maybe vertical scaling options.
Yeah. Let's first talk about horizontal scaling, because that's really cloud scaling, right? Clouds generally don't let you change the instance size of a running instance. And so we do have a construct called a server array, which is a cloud agnostic scaling construct. So you're not bound to the underlying cloud. You basically you can define your server array parameters such as when to scale. The options there are, you can just do it manually. I can say, add a server, remove a server, remove a server. Or you could do it on a calendar. So maybe every Monday morning you need 10 of these servers because that's finance needs to start doing their job. Or it can be auto scaling, right? Based on, if you remember the monitoring and the alert mechanisms I described earlier, that same infrastructure can be used to drive auto scaling. And basically, it'll scale up, it'll scale down, it'll, as you need. The parameters, there's various parameters which we don't really have time to get into, but basically you can define, the maximum you can grow to, the minimum you always need, how many to scale up each time, how many to scale down each time, things like that. Now, when we start talking about vertical scaling, it's a little bit more interesting because, like I said, you can't really, generally clouds don't let you change the size of a running instance. Now, I know things like VMware does, but that's a virtualization tier. So there are, basically the general model is if I want to change the size of a running server, what I'll do is I'll spin up a new server. So I'm not really changing the size of the running server. I'll spin up a new server. Again, because I have my server template defined and revved, I know that I can spin up an exact copy of what's running. If I need to transfer any data, if it's a stateful machine of some sort, and I'll transfer the data. But when I spin up that new server, I'll use that server template. I'll use a different instance size at that point, transfer the data, and shut down the old. Now, if I can stop the server, if I am allowed to stop the server, in RightScale you can basically bring it down, terminate it, but the entity will still be there. It'll look like, if we look at this view here, like this load balancer is an inactive server. It exists in the sense of RightScale knows about it, but it's not running in the underlying cloud. At this point, I could actually change the size of it and then relaunch it. So you have those sorts of options.
Great. We have a couple of pricing and cost questions. So one is it possible to enter custom pricing tables as in the case of using a volume discount provided by a cloud vendor?
Yeah, so there's a couple
maybe markups and
right.
Talk about markups and markdowns.
Yeah, so in Cloud Analytics, for each of your accounts, for each of your cloud environments, you can add a markup or a markdown, plus or negative percentage to add or diminish from those. We'll also do some consumption on your part if you have an EA where we can start reflecting, some of those variations.
Great. And then one last cost question, and then we'll wrap it up. We had a few questions we didn't get to, but we'll try to follow up with you guys individually if we didn't answer them. So the last question, how do you handle cost chargeback, or do you deal only with cost charged by public cloud?
No, so those reports I described earlier, basically, they'll give me a full spreadsheet if I attach it of the cost over that period. So if I was doing like a monthly chargeback scenario, I have this CSV, I can use that, and that'll, in this case, right, so just to kind of reiterate, in this case, I'm going to get a report that covers everything that meets these criteria, which, in this case, will be things that are running in VMware, things running in Amazon, things running in Google, things running in Azure, because I happen to know I have all 4 of those environments tagged as such. So that report that I get, that CSV that I get, I can then use to do a show back type of operation with the, in this case, with this cost center. Whoever's in charge of this cost center, I can say, look, this is how much you were spending. So pay up.
And also, if you wanted to create a report, for example, let's say across all the users in your organization or part of that in your organization or a particular cloud that could show you using the tags who's getting charged back what, that could get loaded into your accounting system or whatever financial systems you're using, that's also possible.
Yeah, absolutely.
Okay, great. All right, well, thanks everybody for taking the time today. We ran a couple minutes over, so we'll let you go and look in your email box for a link to both the slides as well as the recording.